All right, this is Josh Mandel with something a little bit different today. I am going to be doing a deep dive into the W3C Digital Credentials API. And this is an area I got interested in probably back in 2018 when I started going down into this world of decentralized identifiers and verifiable credentials. And then I got to go a bit deeper as part of the COVID pandemic response when we did work on the smart health cards specification, and then later the health links specification, which are all about creating these kinds of verifiable or non-verifiable data payloads based on FHIR. And this is work that has been taken up by some of the major labs and pharmacies and EHR vendors. And it has seen just now a round of standardization through HL7 International. So we are on the cusp of publishing the first standardized version of smart health cards and health links through HL7. And so I've been thinking about this space for a long time, and we have paradigms for sharing these kinds of verifiable credentials today, but they can be a little bit awkward. They don't always integrate that well into the workflow. So a typical pattern might be I would show you a QR code, or I would have to send you a long link that would be a way to download the information that I wanted to share. Or maybe I would scan a QR code from your phone into mine. These kinds of patterns work, and they don't require a lot of deep integration, but they do require people to have the right kind of apps set up, and it can be awkward to scan a QR code in some cases if the data that you want to scan in the QR code is on your phone, but then you also need to scan it from your phone. It can make it a little bit difficult to work with these kinds of payloads. So I was really interested when I saw this blog post from the Google developer blog on Chrome announcing that they have a new API that is ready for more advanced testing, which is called the Cross-Device Digital Credentials API in Chrome Desktop. So let me give you a quick sense of what that means and why it was interesting to me. The basic idea here is that a user who is running Chrome, whether it's on their phone or in a desktop browser, might go to a website that creates a request for a digital credential of some kind to be shared. And now maybe that user has various wallets on their phone that are storing different kinds of credentials, different kinds of digital information packages that might be relevant to a certain request. So maybe the request goes out that says, hey, do you have any health insurance cards or health insurance details that you want to share? And that request might match a card that's stored in something like Google Wallet, or it might match a card that's stored in the application that you get directly from your health insurance company. Maybe they have an app that itself is able to provide you with that data. So the interesting thing here is, as an end user, you might have various wallets on your device that all store different kinds of credentials, and any given request might match any one of those things. And so morally speaking, if you think about how to service these requests, you could sort of send a copy of the request to each wallet on the device, and each wallet could say, yeah, I have a card or multiple cards that would meet that request, or I don't have any. And that generally works, but it introduces some privacy concerns. So for example, maybe your state has issued you a driver's license, a digital driver's license, in an app that they provide to you. You wouldn't necessarily want your state app to learn every time you sign into a website or every time you want to do an age check. The privacy implications there are much worse than we are used to in the physical world, where the state gives you a driver's license and you can use that as often as you want and show it to anyone you want without the state learning about the fact that you're going into this particular business and using your state ID in that way. And so what Google provided is a very flexible request and response protocol where, morally speaking, they do fan out the request to every wallet, but technically speaking, what they actually do is they ask each wallet to register a binary blob in the form of a WebAssembly binary that can run in a secure sandbox that the platform manages. So every time a request comes in, we'll go ahead and run the WASM binary from each wallet that has seen fit to register one. And that WASM binary can respond and say, yep, I've got some cards. And then a standard set of card metadata is displayed to the user so they can select which card they want. And only after they select a card will they be sent to the application, the wallet, that managed that card. So the flexibility here is really excellent. We don't have to standardize the request data or the response data. We don't have to standardize the presentation or the credential formats. We just standardize a very, very thin layer called navigator.identity.get. And that takes an arbitrary request and returns an arbitrary response. So there's a lot of work happening in order to standardize all the fields of those requests and responses, and I'll touch on that in a little bit. But to get started here, I wanted to build a demo that did sort of the simplest thing possible, and that was a really good fit for the kinds of data we store in smart health cards and smart health links. So I built an Android app that looks like this. Always a reminder that I'm not a user experience designer, but this is intended as a technical demonstration. And the idea here is this wallet right now has no credentials in it, but I can paste in a smart health link. This is sort of an onboarding step. And now I have registered the manifest. What does that mean? It means that I've sent that WebAssembly blob into the Android operating system. And the WebAssembly blob has just a little bit of metadata about the details in that smart health link, the FHIR resources that have been stored, and so forth. Let me show you what that actually looks like under the hood. So this is the kind of information that goes into what's called the Karen Digital Insurance Card Implementation Guide. So you've got detailed information about your insurance coverage, all of your plan numbers, the coverage window, who the member or various members of your plan might be, who is the primary subscriber to that plan, and so forth. It also has information about branding, like logos and color schemes, information about costs, deductibles, and so on. And this is just kind of a pretty view of the information. But really what's happening under the hood is anybody with this smart health link, which we see on the URL here, can retrieve a structured data payload associated with the health link. And in this case, it's a FHIR bundle that has the coverage resource and the patient resources that explain all the details of this person's insurance coverage, as well as the branding information that you could use to render a nice looking card from it. So this is what I pasted into my little Android wallet here. And the reason I've gone through that effort is so now I can show you an example of a relying party application. Before I'm able to show you the relying party, I should mention this is still an experimental feature in Chrome. So you have to turn on the flag explicitly, or as a developer, you have to request permissions on a specific domain where you want to use these APIs to prevent your users from having to enable this flag explicitly. But you can see I've got this turned on here. The basic modes are enabled and disabled. But you can also see Google is really wrestling with the user experience and privacy implications here to try to communicate to users exactly what is happening when they go to share data. So in this example, you could see you could turn it on with no dialog box. You could turn it on with a mild warning. You could turn it on with a severe warning. I haven't tried a severe warning before. I'm not going to do it now because it'll force me to reload my web browser. But I have it just turned on with a default warning. So let me show you what this looks like then in a relying party website. The idea is this is a little test bed, but you could think about this like a clinic website where you're registering for your first appointment somewhere, and now it's time to share your insurance card. So typically what would happen is there might be a button here that would help you take a picture of the front and back of your card, or maybe there would be a way to paste in a smart health link that you somehow put on your clipboard. But today I'm going to show you this navigator.identity.get API, and I'm going to show it to you cross-device. So the left window here is my desktop Chrome browser. The right window here is a live share onto my local Android phone. So here's what happens when I press the request button in the browser. It's going to initiate a request with the default level of warning scariness. Do you trust this site with your data? JoshuaMandel.com wants to use personal information from your digital wallet. At this point, if I click continue, nothing will be shared. I'll just get the opportunity to share. And this is a cross-device workflow. So my desktop shows a QR code, and my phone can scan that QR code. The button here says use passkey, which gives you a sense of the fact that they are reusing or maybe leveraging some existing platform capabilities around passkey flows, but they haven't quite got the branding right in order to represent the fact that we're doing a digital credential share here. But I'm going to hit connect devices because I trust these devices. Under the hood, there's a check that's happening to make sure that my laptop and my phone are near one another. So they both have to have Bluetooth enabled and they have to both be in range. And now my phone is showing me this dialog here that says you've got one card that matches the request. That's a smart health coverage for Jane Doe card. And it's got several different attributes that'll be shared. So this box here, this was the output of my wallet's WebAssembly matcher binary. My WebAssembly matcher said, go ahead and create a card that's going to have all these attributes, and then each one has a name and a value. And I think I've taken too long here. So this has timed out as I was trying to explain the demo. So what I'll do instead is just reinitiate the request, scan this QR code again, and instead of talking through the whole thing, I'm just going to go ahead and show you the flow. So I'm going to click View Details. Assuming I'm happy with these details, I'm going to click Continue on the phone. And now I'll be presented with a screen from my wallet, which in this case, it's not a very sophisticated wallet approval screen, but it has the opportunity to review the full FHIR data that you're going to be sharing if you click Continue. In my case, I do want to share it, so I'm going to click Share Credential. And then I'm successfully returned to the web browser. And in this case, you can see the query that went out was, do you have any insurance coverage resources that meet this Karen for digital insurance cards coverage profile? And the response is a verifiable credential in the form of a smart health card. So my web application could read this, could check the signatures on it, and so forth. So that's the basic flow. And what I love about this is it allows me to define my own protocol. In this case, I defined one just for sharing smart health cards. And only wallets that want to share smart health cards need to implement support for this protocol. And it was very, very lightweight because the requirements for sharing a health card or a health link are themselves pretty lightweight. I should point out that there are much more sophisticated protocols that can also be used to initiate these kinds of requests. And one of the main protocols here is called OpenID for verifiable presentations, OpenID for VP. And there have been 20 some odd drafts at this point. It's still being finalized through the OpenID Foundation, but you can look at what a request here looks like. My request just had a FHIR resource name and a query. These requests are quite sophisticated and flexible. So the OpenID for verifiable presentations standard, first of all, has a whole query language called the Digital Credential Query Language, where you can say what kinds of credentials you're willing to accept, which issuers you're willing to accept. You can say, I need specific claims available to me. You can register as a client. You can even encrypt the entire payload so that the browser itself can't read it, but only the target wallet's going to be able to read it. You can sign your request so the target wallet can verify who created that request. So a lot of sophistication here. And then the OpenID for verifiable presentations spec is also very flexible when it comes to the underlying credential formats. But one of the credential formats that's seeing a lot of investment is called mdoc. So this is the Mobile Security Object for mdoc. And this is the standard that's been developed by ISO as part of work on digital driver's licenses. So in states in the US today that offer a digital driver's license, that's generally issued in this mdoc format. And it has a very sophisticated binary protocol using CBOR, the concise binary object notation, CBOR signatures back and forth. There's a whole protocol between the requester and the responder. It describes what happens when you tap your mobile phone at a security checkpoint with TSA, every byte that goes back and forth over the wire. That's all information that the mdoc, or Mobile Driver's License Standards, specify. And so OpenID for verifiable presentation can support any number of standard formats. mdoc is one of them. So the flexibility here is great, but the complexity is also quite considerable. And we're just starting to see kind of what generic tools will emerge that can make good use of these kinds of sophisticated capabilities in a consistent way. Really exciting time to be tracking all this and be able to test things out. One interesting thing, I mentioned a lot about the Google, Android, Chrome architecture here for keeping these WebAssembly modules and sandboxes and maintaining privacy this way. Apple is likely taking a different approach here. I think there's not any super public information about what they're planning, but this blog post here at Corbato has at least one person's guess about what you're likely to see from iOS, and that guess is that they might launch digital credential support in Safari in time for iOS 19, but that it's most likely going to be focused just on mdoc. So it might not have all the flexibility of the matching system that Google has developed, and it's not clear yet whether it's going to support multiple wallets or just one. My guess is that they will have to support multiple wallets in order to be competitive in the European market, which is starting to lay out a whole set of very sophisticated requirements for what an EU digital wallet needs to be able to do. So there's some strong regulatory pressures that are beginning to form here as well. Very interesting time to be involved in this work. I want to say that everything I showed today is available in a repo called SHL Wallet. It has a few main components. One is the website that I showed you, the requesting party website. That's just a simple HTML file. Another is this matcher, which I developed a Rust language matching library in order to match credentials to requests. And then finally, there's an Android app, which presents the wallet and manages the registration of those credentials and handles the smart health cards and links. So all those components are part of this repo. And overall, I'd say this was a good learning experience for me. It's fun to see how far this technology has come. It's actually available in a platform that reaches a large number of users today, albeit in alpha mode. And there was definitely some pain points associated with this alpha mode. Some of it was just small things, like the documentation is out of sync with the actual function signatures that have been published as part of the Java and Kotlin packages here. Fortunately, the compilers are pretty good at noticing when your function calls have the wrong arguments. So that was not really a big deal in terms of a slowdown. The really tough thing for me was if you read the API documentation, it seems like you can register your credentials with the platform using any type you want. The type is just a string. And so typically you would pick one that sort of met your own app's domain name, but anything would be valid. And indeed, you can put this and your registration request will succeed and everything will look great. But for some reason, your cards will never match unless you use this value, com.credman.identity credential. That's kind of a magic value. It does show up in the Google reference code. And it was really, I was at my wit's end trying to figure out why nothing I registered was working, and eventually started just pasting chunks of the Google reference code into my own project and not really expecting it to work. Suddenly, cards started appearing, and I realized that this is actually a magic value that is the only one that seemed to work, at least for me, on the particular version of Android that I was using in the emulator at that time. So that was very, very painful. And the other painful area right now is I love this WASM sandbox design, but it's not really very well documented. There's some reference code in C, and then they publish the compiled code as WASM, but they don't actually describe the compilation parameters. So it took me a little while to sort of reverse engineer the compiler settings that would have been used to create these. And I think the bottom line is that you need to compile against a WASI target. And then there were still a couple of additional setbacks on that front. Anytime your code crashes, you basically just don't see any matched cards come out the other side. And so it could be hard to tell if your code is crashing or if it's just not returning any cards. But eventually I built a very, very simple matcher that just always returned one static card. And even that wasn't returning any results. And I figured out that this seems to be because anytime I would try to construct a new hash set, my program would instantly crash. So it seems like there's no entropy source available in this WASI environment. So, just another gotcha, and just having clear documentation of what is and is not available and how to compile your code, that would just help a ton. I probably wasted 2 days trying to debug these issues together, and it was particularly painful because I couldn't tell whether the problem was here or here. These were 2 steps that needed to happen in a row, and there was actually no feedback from the platform about any failures, so I just had to guess and check until eventually I saw something come through the other side. So it's still alpha, still very early. The APIs are going to change, but I was able to get this working, and it was a fun project to be able to tie these pieces together. Last comment I want to make is I've been posting a lot about large language models recently, and I haven't mentioned LLMs at all today. I do see a couple of really interesting and important roles for large language models, even in this world of credential presentation and selection. So one is selective disclosure. I mentioned that for the mdoc specification, we have the ability to model several different attributes, and then a client can come by and say, I only need to know that this user is over 21. Or I only need to know their last name. I don't need to know where they live. All those kinds of selective attribute disclosures. But when you get into something more complex, like a FHIR bundle that's got very detailed, nested, complex JSON structures, if you tried to represent every one of these as a different attribute, it would be totally overwhelming to the user. Do you want to share information about your deductible? Maybe that's not privacy, not a privacy issue, but do you want to share the names of all of your family members? Do you want to share some of the underlying address and phone number details? Those could have certainly could have privacy implications. And so if you wanted to make something like this selectively disclosable, you'd have to sort of decide ahead of time on exactly which attributes should and shouldn't be disclosable. And then you could issue something like a mobile security object if you're using the mdoc spec, or you could issue a SDJWT, selective disclosure JSON web token, which is a super cool specification that's making its way through the rounds of finalization in IETF. where you can basically define cut points in your JSON structure and make those cut points selectively disclosable. But you might have hundreds of cut points, and you definitely would not want to overwhelm a user with hundreds of choices or a developer with hundreds of choices about what to disclose. But you could definitely imagine a large language model looking at the full resource structure and deciding which subnodes of that JSON would need to be shared in order to make the right kinds of disclosures to meet the requirements of the relying party. So LLMs are really a great tool for bridging between this very hard-edged, sharp world of selective disclosures and cryptographic hashes and pre-images that you need for selective disclosures. LLMs are great at bridging between that and this squishy world of explaining intents and actually looking at a data structure we've never seen before and maybe even making a choice about which nodes need to be exposed to make the right selection. So that's one role where I'd love to do some prototyping. I think LLMs would introduce really interesting capabilities there. And the other one that I think would be super fun to prototype is what I might call the clipboard killer, which is you've got a health wallet application and you want it to be able to help you fill out questionnaires. Maybe you've got a particular intake form from a new clinic where you're going to be having an appointment, and they just want to request navigator.identity.get and send along a questionnaire for you to fill out. Now, this is interesting because it's sort of taking advantage of the flexibility of this protocol. You might not have a digital credential representing the answer to that questionnaire. That might not exist in any pre-baked form. But a matcher could raise its hand and say, I have the capability to help the user fill out questionnaires, and I have a bunch of health data that is going to help me do that in a more automated way. And so the matcher could return a card that basically represented that fact. And if the user selected it, they would be steered into the right wallet application, if you will, or digital health app that would be able to use that patient's history and be able to present just the questions that couldn't be answered from the history, driven by large language models to help the user fill out the questionnaire. And then by the time we returned a questionnaire response, a FIRE resource back to respond to that request, everything could be filled in a very structured and neat way. And this is a great example of something that really only works if you have the flexibility of being able to define your own request and response protocols. You might call this a clever use of the existing APIs. Some people might call it an abuse of the APIs, but for me, this is what makes the web so fun and dynamic, which is once you lay out this foundational capability, you could be very clever in exploring new ways of tying these pieces together. And for me, that's why this Android and Google Chrome design works so well. And I'm still waiting to see what we get from Apple, but I guess I'm concerned that we're not going to see kind of ubiquity of this flexible design. We might see very, very locked down approaches, but time will tell. So that's a lot about digital credentials. Hopefully you've learned something. I certainly learned a lot putting this together. And don't hesitate to reach out with ideas about use cases or other areas that you want to explore. And until next time.